Welcome to Analyst Crossfire, an ISC 16 panel featuring expert voices from the international supercomputing community giving their reactions to some of the top HPC trends discussed at this year's conference. I'm Addison Snell with Intersect360 Research, and I'm the moderator for this panel. And once again, the ISC organizers and I have selected 4 experts with different perspectives from across the HPC community, and these 4 have volunteered to play the analyst by sharing their personal opinions on current and future supercomputing trends. For the first time, Analyst Crossfire is being presented as a track focused on high-performance computing in industry, and our panel represents that, starting with a pair of vendors of HPC technologies. Gilad Shainer is a VP at Mellanox. Hello, Gilad. And a company we started to see more of in the HPC space, Francis Lam, the Director of Product Management at Huawei. Thanks for joining us, Francis. Next up is a longtime, well-known leader in high-performance computing for aerospace, Gerd Büttner, the HPC architect for Airbus. Hello, Gerd. And finally, you saw him on stage during the keynote on Monday, representing a globally recognized leader in hyperscale and machine learning, Bryan Catanzaro, senior researcher at Baidu. Thank you, Bryan.
Hi.
Panelists, thank you all for joining me for ISC Analyst Crossfire. The clock's running. We're going to get started. Issue number 1 is machines for learning. We've heard a lot about machine learning this week, and it's very exciting to think about the potential of machine learning going forward. The question I have to start this panel is, should HPC system vendors, platform vendors, start designing systems specifically with machine learning in mind? And if so, what should those systems look like? Gilad, I'm going to start down at this end of the table and go with you.
Okay. First, I disagree. No, sorry.
It's a fast panel, Gilad. Get going, man.
So the answer is yes. I think people are building today specific systems for machine learning. We see designs, for example, from NVIDIA that actually build a box that has multiple GPUs and 4 InfiniBand adapters to deliver aggregate bandwidth of 400 gigabit per second from a box. So I think the requirement for machine learning are a little bit different than other applications in some aspects, and therefore, yes, people will design systems for machine learning.
All right, Francis, what do you think? You are a platform vendor. What are you going to do, a special system for machine learning here?
Yeah, this is already happening.
Grab a mic.
This is already happening. So on one hand, I think there are very specialized requirements for machine learning, so it's bound to happen. But on the other hand, I think this is the beginning of a field that is going to be have a very broad set of applications, and so it's sort of a moving target, right? We've seen people building special purpose machine by repackaging the form factor, as well as customized on the chip level. So I think this is something that's going to happen, and it's happening.
I'm going to push you a little bit, though. You said, so yes, this specific platform, but you said reconfigure, repackage, special chip. Can you be more specific? You're going to put out a system for machine learning. It looks like what? What's the configuration?
Well, what I meant is that today what we've seen people are doing are repackaging the boxes, right? The range, the sizing and the configurations to add different type of hardware accelerator. To make it work better, and we've also seen people try to muck with the processor, the chip itself, to add some level of hardware acceleration within the chip for specific purpose of acceleration.
I'm going to back up to the Gilad for a second before I get down to the other end of the table, because you both kind of highlighted the chip itself. Gilad also mentioned the interconnect. Does it come down to it's a system with these chips and this interconnect, or are there other aspects of the platform that you need to think about?
From a platform perspective, there is other aspects, because if we take the software as part of the platform, then yes, there are different aspects. I think there is a different configuration from which elements you put there and how many of those elements. For example, today you're looking to put more GPUs in a box, for example, and be able to drive more bandwidth in some areas. There is also specific algorithms that is being used in deep learning or artificial intelligence.
All right, I appreciate that, and I'll hit that in a second. Gerd, automotive might start looking at machine learning. Do you need a specific platform for it?
I think yes. I like to have a specific platform, but I don't like to focus too much on the chipsets. I like to have really standard interfaces for hardware and software to be able to adapt whatever I like to do. Maybe also forgot not in the system something like the linked data system, what is really to enable us to link the data what we have in production available to machine learning. And software should stay as an open source as it is for now, and hopefully it will stay. And you shouldn't forget, and that's for me is one topic on the big data, don't forget the IoT big data environments to keep it aware.
All right, so if someone comes out with that machine learning platform, you're ready to sign a purchase order for it? You're going to buy one?
Yes, maybe.
Yes,
I'm
maybe.
working
All right.
research.
Maybe is not bad. Brian, you're the expert here, which is why I saved you for last. Presumably you do want a platform for machine learning, so what should it look like?
Yes, and I think people are building them already. Machine learning workloads, at least the ones that we do at Baidu, are very computationally intense. So we want something that has really computationally dense design. And also I think the I/O requirements are somewhat different. One of the things that's giving me fits right now is parallel file systems, and I think that the access patterns that we really want for deep learning to our large data sets are quite different than you might find in computational fluid dynamics, for example. So I'm really hoping that we can come to figure out what the right solution is for how we're going to deal with our data.
Now, while I'm down there, I want to follow up on what Gilad said, which is the software, as part of the platform. We don't really have. There's a few benchmarks out there, but are we going to get to where there are discrete machine learning applications as part of this platform? What do those look like? Are they by industry or what?
That's an interesting question.
Well, then pass it to Gerd, because he'll think about it just for automotive for a second. Are you going to have just an automotive machine learning application?
Not from automotive. I'm looking more for machine learning application for the manufacturing part. We are starting a lot of factory of the future activities, and I like to have the IoT and the machine learning because we have to educate something like robots to collaborate with people. That's a totally different subject, but it's really deeply involved in this machine learning exercise.
Brian, did you think of a specific application you want?
Well, so what I wanted to say is there's a big difference between training and deployment. And typically when we talk about machine learning in HPC, we're talking about training, which is the research side of machine learning. How do we come up with new models that solve new problems? I think applications that get deployed to solve customer needs and are kind of standalone are really important too, but I think HPC is less important there.
Issue number 2, Chinese takeout. China has the top 2 spots on the top 500 list right now and the most systems overall, which ends the long streak of U.S. leadership in that statistic. Should the U.S. or Europe or Japan accelerate their own supercomputing initiatives to respond, and will they respond? So should they and will they, Brian?
So I work for a big Chinese company.
I'm aware.
And I have to say, one of the things that I've really enjoyed about working there is working with my Chinese colleagues who I find generally really bright and really well motivated. So I'm not surprised that China has been making progress in HPC as well. However, I don't view these things in terms of nationalistic competitions. I think HPC, if it provides value, it will get investment. And so I think for the question, should other countries accelerate their investment? I think the answer to that is, well, does it make sense? Like, is there value in it? And if we believe here at ISC that there is value, we need to do a better job of demonstrating that to the people who are paying.
Do you think they will do it based on the Chinese?
I hope that they don't do it based on the. I feel like it's depressing to work in an environment where the goal is to, keep up with the Joneses.
It sounds like you're afraid they will, but you don't want it to be for that reason.
I want to change the world. So if people decide, hey, HPC is changing the world and we should invest in that because we want to make the world a better place, then I want to do that.
Gerd, should they and will they?
Yeah, go ahead.
Okay. For me, logically, I know there's a lot of initiatives in Europe, but not for the very top end of the systems. Independent, there's some exascale programs in Europe. On European level, but logically I would say from the industry point of view, I don't take care who leads. I need really something what is operational, and this is not the top end of the system. I don't know any really application which requires millions of cores for one job, except Linpack maybe. But
all right, I'm going to come back to that in a separate question. You're officially lodging an answer of don't care. Francis.
They should.
They should.
I think competition.
There's the first guy answering the question. I appreciate
I
that.
think competition is fun. I think competing in that level it requires some groundbreaking and innovation, right? By engaging in such kind of competition, interesting things happen, and would eventually, we would get better technology.
All right. Well, will they? You said should they? Yes. Will they?
I have no idea.
No. You're not willing to go on record with a prediction. Gilad, should they? Will they?
So first, I think the Chinese system is by using, and I need to take the vendor part here, by using the Mellanox devices inside and building a system like that at 41,000 nodes and more than 10 million scores, I think it's a good testimony for equipment or hardware that can actually scale to those kind of sizes.
It's a great engineering project,
Now-
and I love the chip. I do.
Now, I think the people is doing that not because of competing, because supercomputing become the resource for driving national science, research, and so forth. And as we move forward, we'll see more and more need for supercomputing. So I think that element within China will drive or accelerate initiatives in other places.
So you think it will?
Yes.
I'm on kind of should they? Well, it doesn't really matter whether they should. Will they? Yeah, I think that's going to come. But let's get to the other half of this question that's implied. Where do you think the Chinese capabilities in supercomputing really truly rank right now relative to other nations, Gilad?
I think they made a huge jump over the last few years, and I think they're building a system right now that's actually being used for things, not just limp-punk machines.
They have what, 3, 4 Gordon Bell applications
Some
on
of
that
them,
now?
yes.
Already running, so you're right.
I think they're doing an amazing job. I think they're building systems that actually drive research and science within China, and I think yes.
Well, good. Francis, what do you, where is China now? I guess I really didn't get a sense, Gilad. Do you think they're, are they ahead of everyone else right now? Or
No, I wouldn't say that they're ahead of everyone else. I think that they're in the leading position. I think there is other folks in the same leading position. I think what's happening in the U.S. is a great thing. I think there is other initiatives within Europe and others. I wouldn't put them in number one, but I said there is several countries and several areas that actually lead over the others, and China is one of them.
Francis, what do you think on that?
Well, I think no matter it is in China or in other part of the world, there is a lot of interesting problems to be solved. I think now that we have the computing capacity available, a lot of interesting application would happen.
Well, that's almost tautological. I mean, the great thing about supercomputing is there's always a harder problem to solve, right? Until we wake up one morning and decide we've reached the end of science, it's done, right? We've solved science, check that one off, great. There's a harder problem. Gerd, where do you think the Chinese rank now overall?
For me, I think the Chinese made a very good job, really, to improve, but I'm not sure where it's really used, and I don't see the huge differences depending on the top 3, top 5 supercomputing center, because they do more or less a very similar job. For sure, it helps to support, to develop new systems, new technologies, but for me, the gap is growing to the standard system we have to use in the industry area.
I agree with that also. Bryan, I intentionally saved the last word for you again.
I think everybody has to acknowledge that China is a leader in HPC now, along with other regions of the world. So I'd say
a leader, not the leader.
I mean, personally, I don't have enough context to say like who's winning the race, but I have to think, they've made a lot of big investments, and there's been a lot of fruit that's come from it.
Gilad made the right point that there are real applications running on this. It is not a very versatile system. It's good at one type of application, but there are lots of systems that are good at one type of application.
I'm actually interested in the depth of the top 500 list that China has engaged with, right? So it's not just the #1 system, but actually 167 systems on the list.
Well, I maintain it's not that China suddenly discovered supercomputing. I think they suddenly discovered the top 500 list, right? And there's a lot of systems coming on there now.
I think it shows breadth, right? So I think we don't need to focus just on the #1 system to acknowledge that China is a leader in HPC.
Gerd, here we go on the topic you really wanted me to get to, which is forget-me-not. With all this focus, we're talking about exascale, we're talking about new application paradigms. Is enough really being done to bring along traditional legacy high-performance computing applications in science and engineering, and what more should be done? And you're champing at the bit, so go ahead and get in there, Gerd.
Okay, for me, logically, I saw some initiatives, but far not enough. I know there are some companies really step in, doing some good work with labs, but I know there's a real problem in the software area, because it's a lose-lose game for the software companies. If they develop a no-code, we don't buy so many licenses, so they lose one time the money to develop a new code, and second time they lose the recurrent costs we have for licensing. So it's a lose-lose game for them. I don't know, have a good solution for, maybe go for what I see in some areas, to go for open source, to may put the code back from the private area to the public area to get an improvement. But logically, I don't see really a lot of scalable solutions in the industrial field.
I want to try to come back to that in a second, but let me hit the rest of the table first. Francis, what do you think on this?
Well, I think there are more than one way to solve the problem. I think it's, at the end of the day, it's a financial issue, whether you have the sufficient ROI to migrate your legacy code.
I just gave you 5 points on my sheet. Go ahead, keep going.
Onto newer platform. But vendors like us, when we also produce more traditional high-end SMP system based on x86, so legacy Unix code can potentially migrate onto that, but somewhat older architecture is difficult to move on.
Brian, I don't know where you weigh in on this. You don't have a lot of legacy HPC applications hanging around, do you? Do you want to help solve them?
No, everything at Baidu is rewritten practically every year, so it's a fast-moving place.
What language is it written in?
We mostly write in C++ and Python.
There you go.
Yeah.
There's a lot of C++. HPC is still mostly C and Fortran along with C++, though. Python's been coming up more.
I haven't seen any Fortran code at Baidu. Sorry,
Yeah,
HPC people.
look around at some banks. Gilad, what do you think on legacy applications?
I think the answer is no. So, we live in a situation where we see more capabilities being moved out from the CPU to essentially being executed in other devices, such as a network. And
Sounds like you're advocating for something like in-network computing.
I'm covering your both sides. So one thing, ability to run ability to run MPI framework on a network actually enables you to accelerate any kind of application, regardless if it's traditional or new. But the major advancement of applications would come with moving, for example, the use of applications of blocking communications to a non-blocking, to asynchronous progress. This requires you to actually go and change applications. What you can get from it is essentially you can get the almost full overlapping between compute and communications, which is a holy grail you can achieve. But that requires to actually go and change applications. If we don't do it, then we'll get into a position that it doesn't scale.
I mean, you're hitting right on the exact problem here, is that all of these things require you to make application modifications, and that's why a lot of these things are getting behind. And Gerd, I wanted to come back to you on this point to what Francis actually said is, there becomes a monetary problem. And what's the monetary incentive? What is the market motivation for advancing these codes, either as an ISV or as the open source? You're talking about pushing it to open source, so people are going to do it for love and oxygen alone or something, right?
Not really only for love and oxygen, but if the open source community is always interesting to get ideas out of code and maybe some interest to modify code and maybe sell services based on the code, that is for me the driver from the open source community, what we can step in, because the commercial companies themselves have a really financial issue behind, and logically we don't like to pay more for the licenses, and that's it's really a problem.
No, software scalability got harder, but everyone wants to pay less.
Yes.
Okay, so any solution for that, or are we just go home?
Not really up to now. Therefore I said, okay, open source might be an opportunity to move it back. I see this already for some companies. They push back their commercial code. They took up for several years to private code and push it back to the open source community. Maybe this is one way we can go. Logically, you have to rewrite the code. And if you look on the code, we see in the CIE area, for example, it's written code in the 80s, maybe middle of 90s. So normally written in C or Fortran or whatever. So to modify the code is not really an opportunity. You can have adapted system. There's a lot of things done by some middleware layer to improve the code. But logically, you are always on a boundary condition. And I were very provocative to some of our engineers saying, maybe in 2, 3, 4 years' time, you can run all your application on a single chip if you have 500 cores available. And that's not so far away. Then why
Francis, very fast. Is open source the answer here?
Yes.
Francis, is open source the answer?
I think so.
You think so? I think the trouble with some of this free software, though, is sometimes it's not as much like a free ice cream cone. It's more like a free puppy, right? And they require a little bit of care and feeding. All right, that was our long answer for Matt. We're on to the speed round. Stuck in the middle, looking at these middleware areas, development environments, cluster managements, et cetera, which is a better idea? Standardizing middleware across platforms, a standard set, or do you want to specialize the middleware to suit specific architectures, Francis?
I don't have an opinion on this.
I sent you the question in advance.
I know, I know.
This is a hard question.
I know.
All right,
Yeah.
so you don't know is your answer. All right, what do you think, Gilad? You've got an opinion, I know.
Always. No. I think definitely standard ecosystem, open source, that's the key to drive anything. And from my perspective, yes, it is better to go and standardize middlewares across platforms as much as you can.
So something like OpenHPC is a good idea?
If OpenHPC works on any platform, yes. If OpenHPC is optimized to a specific platform, then not.
Gotcha. Bryan, what do you think on this? You want standard middleware set or specialized middleware set?
I want standard because I think when you ask programmers to use an environment, you're asking them to invest their lives figuring out how it works. And if they have to waste their time on something that they can't use in the future, that's a big opportunity cost.
Okay, Gerd, I'm really interested in your answer here. What do you want the middleware to look like?
On the middleware, I can say very simple. I do have a standardization, especially if for the developers, if we go for cloud approaches, we cannot adapt code to different middleware platforms. So if we like to go for cloud approaches, what is hardly in discussion in a lot of industries, it can help only. You cannot adapt code for every specific environment. And if we go for the customers themselves, for the GUI, yes, there may be something like standardization, but capabilities to manage really the different environment should be in this platform integrated.
I think the standardization is a nice idea, but given the specialization we're facing in the hardware, it's a hard utopia to chase. Parallel file systems, are these ever going to get widespread adoption in commercial markets beyond oil and gas, Gerd?
Yes. I think yes. I see a mind change ongoing in the industrial more and more. If we talk about object storage and really parallel file system, we are discovering more and more that we are on the limit of the sequential file system. So there's something ongoing.
Bryan, you said these are giving you a nightmare here, parallel file systems. What do you think?
Yes, I think ultimately they will get more adoption. I think widespread is a weasel word, so it's hard to know what you mean by widespread. But yes.
Currently running at about 15%.
Yeah, I think it's going to grow. One thing that is really irritating to me about parallel file systems is that they're hard to set up and administer and maintain. In the hyperscale space, you know, a lot of people use HDFS, which I don't know if that counts. Probably not. It probably doesn't count as a parallel file
It's a little bit of a
system.
different architecture.
But the thing that's really great, so like I can't use HDFS because it's way too slow for machine learning, but the thing that's really great about HDFS is that it's easy to set up and maintain, and I wish that the parallel file systems were that good.
Well, they're less robust than the other ones. Gilad, what do you think?
You know, I agree with both Gerd and Bryan.
Well, then that's fast. Francis, are you going to have an opinion on this one? I give you a rest.
I think there is a lot of existing commercial use for parallel file system already. I don't know from a percentage.
I mean, you can count to a bunch of users, but it's still only 15% of commercial.
You know, even our company has a number of our own proprietary parallel file systems. It's different from what you typically use in the HPC environment, but it's happening.
Gerd gets the most points for saying object storage. That's what I think is really going to start enabling a lot of this in commercial, is when you kind of get out of the file and directory mindset and start moving these things to object orientation. Ultimate speed round. How long is it going to take before each of the things I'm going to name here gains 10% adoption in HPC? You can just give me how long. Public cloud or utility use of I run my HPC application in the cloud, Gilad. How long before that's 10% of the market?
Here you need to define a cloud. Is the cloud an Amazon cloud or the cloud is a San Diego cloud?
Francis, how long?
Open for everyone.
Gerd, how long is this going to take, man?
For public
How long is
cloud,
it going to take to answer the question?
for the cloud, I think 3 to 4 years.
3 to 4 years. Bryan, how long is it going to take?
I'd say 2018.
2018. Any of you guys down here want to give a different number?
No, I think my point is that you know, HPC is, well, it's a very broad field. I mean, in industrial HPC, I would think
Including
it's going to happen
industrial.
faster. For academic, it may take a lot longer.
currently running a little below 3% of the market. It doesn't get there within our 5-year forecast. It's more like 8 to 10 years, according to us. Power processors. Gilad, you've got a stake in this game. How long?
10% first, we hope that there is going to be huge flexibility, but I would guess in 4 or 5 years they have a chance.
4 or 5 years. Francis, how long to get 10% of the market?
Long time.
A long time. Gerd, how long before it's 10%?
I would say 20 to 22.
20 to 22. All right, fair enough. Brian?
I'm going to say never.
Never is going to get that. That's a fair answer. It used to be I would have said 2 years, but now there weren't enough wins named this week. It looks a little slower than that. I'm going to have to push out 3, 4 years. ARM processors. Brian, I'll let you start on this one.
Never.
Never going to get there. Gerd?
We need fast processors.
Gerd, how long for ARM?
I say beyond 2025.
Francis, how long before ARM is there?
5 years.
5 years. Gilad, how long before ARM's at 10% of the market?
Yeah, I would make a stronger guess here to talk about 3 to 4 years.
It used to be I would have said never, but then Fujitsu announcing ARM in post-K I thought was really notable. So now I'm going to say probably still never, but it'd make me think longer about it. Last one, OmniPath. Last one's OmniPath. Go ahead, Gerd. OmniPath. How long for OmniPath?
OmniPath, I see 17, 18.
17 or 18. Francis?
A year after Skylake.
A year after Skylake. Brian, how long for OmniPath?
I'm going to say 2019.
2019. How long for OmniPath?
We
Gilad?
need to wait and see.
No, tell me how long, man.
I think this is a question that probably I shouldn't answer. So.
I probably shouldn't either, but I think it's going to happen pretty quick on these systems. OmniPath will get there within 2 years. All right, last traditional question is one up, one down. From your observations at ISC 2016, tell me each of you one thing you were impressed with, like came in better than you expected, and one thing that did not give you as much as you expected. I'm going to start down there with Brian.
Better than expected, Chinese HPC. Worse than expected, PCIe accelerators.
PCIe accelerators is an interesting choice there. The China, nice. I mean, that did come up, I think, a lot higher than people thought it would. Gerd, what do you think?
What I can see, really, commercial products starts work together better than I expected. And what's going worse, personally for me, I have not enough time to attend all the different sessions here in the ISC.
That's kind of a softball answer, though. I mean, the thing is, the ISC organizers are adding all these content areas that people are asking for, including a whole industry track. So now you complain that you can't get to everything. That's kind of rough.
Yes, but it's a reality. Also, you have also the commercial things to do in parallel, so you have only limited time. Unfortunately, that's a reality. You have not enough people from the industry always to stay here.
Okay. Can someone clear the thing from? Thank you. All right, Francis, one up, one down.
The up is, I've seen a lot of discussion that involve, try to do things differently, try to solve the problem, different from with.
The breadth of solutions you're saying is what's impressing.
All kind of things seems to be possible now.
Do you have specific examples of areas of breadth that you weren't expecting?
Doing things on cloud and, using different analytic tools to solve HPC problems and different shape and form of hardware configurations, stuff like that.
I will say this, the breadth of things that we see at conferences like this is really expanding widely, including talking about machine learning as a whole new area. All right, one down from you.
Downside, I think the exhibition is a lot smaller.
They got record attendance.
Really?
Absolutely.
The exhibition, the size, the space, the booth, it seems to be a lot smaller.
Well, so buy a bigger booth next time. What do you?
We maintained the size, right?
The thing is, there's so much content here, as Gerd was pointing out, that you need to do something to draw people to your booth. Instead, don't just set up a booth and wait for people to walk by. Get involved in the sessions that are over here and tell them why they should come to the booth and what they should see. Gilad, one up, one down.
One up, it's the #1 system on the top 500. It's definitely
It was a big surprise.
Yeah, I think from capabilities and what they're able to achieve, I think it's definitely up for me. One down, I think progress on the software side and applications. I think it's not moving fast enough.
And we've seen that, that's the other end of the top 500 list. One thing they pointed out in the top 500 press release is that while the top of the list has continued to go at a steady clip, the bottom of the list, if you rank just the 500th system, used to go at 90% a year growth. And then in 2008, as soon as multi-core hit, that elbowed off, and now it's 55% a year. And I attribute a lot of that to the change in architecture. Thank you, panelists. We're going to wrap up. That concludes Analyst Crossfire. Audience, please join me again in thanking my panelists, Gilad Shainer, Francis Lamb, Gerd Büttner, and Bryan Catanzaro for bravely sharing their insights, as well as the excellent ISC events team for another successful ISC conference. We'll see you next year. Thank you.